Right. See, now let us look at some of the multiplicative factors. So milli, micro, nano, pico. See, the base, everywhere the base is 10. In milli, micro, nano, pico, the sign of the power has to be minus, and then you write multiplicative factors of 3, multiples of 3, that is 3, 6, 9, 12. You write it in terms of multiples of 3, I repeat. The base is same everywhere, 10, 10, 10, 10. Then the sign of the power has to be minus from milli to pico. And then the numbers that you're going to write are in multiples of 3, that is 3, 6, 9, 12, right? How to convert, we'll see. We'll see with the help of examples later on. Now from kilo to giga, kilo, mega, giga, the sign of the power has to change from minus to plus. Again, now you write multiples of 3, that is 3 here, 6 here, and 9 here. So in a nutshell, when I talk of milli to pico, the sign of the power has to be minus, and then you write multiples of 3, that is 3, 6, 9, and 12. From kilo, mega, and giga, the sign of power has to be plus, and then you write multiples of 3 again, that is 3, 6, and 9, right? Okay, so let me give you a couple of examples in support of this. Suppose if I have to convert, say, 5 microvolts into volts. Now how you can do it? See, 5 microvolts, the answer is very simple. 5 microvolts is equal to, see, of course this mu is symbol of micro. 5 into, now micro, just have a look here, micro multiplicative factor is 10 raised to minus 6, right? So instead of this, in place of this micro, I'll write 10 raised to minus 6 volts. So 5 microvolts is equal to 5 into 10 raised to minus 6 volts. This 10 raised to minus 6 is the multiplicative factor for this micro. The other way around, just as we discussed, conversion of meter into centimeter and centimeter into meter, isn't it? So just likewise, as I explained over here, while converting meter into centimeter, you are multiplying by 10 raised to 2, and centimeter into meter, you are multiplying by 10 raised to minus 2, right? So what we were doing is we were simply changing the sign of the power. Instead of plus, you were writing minus, that's all, isn't it? As you can see here by converting meter into centimeter, you are multiplying by 10 raised to 2. While converting centimeter into meter, you are multiplying by minus 2. Okay. So same way I have to do here. While converting microvolts into volts, I am multiplying by 10 raised to minus 6. Now suppose if I ask you to convert 400 volts into microvolts, how can I do it? 400 volts is equal to 400. Now 400 means I can write it as 4 into 10 raised to 2 multiplied by, now volts to microvolts. While converting microvolts to volts, I was multiplying by 10 raised to minus 6. So now while converting volts into microvolts, exactly reverse I have to do. That means instead of minus 6, and I'll write the same number, but instead of this minus, I'll write plus over here. So effectively what you get is 4 into 10 raised to what? 2 plus 6, that is 8 microvolts. Okay. So simply how you can remember this is by converting microvolts into volts, and if I'm multiplying by 10 raised to minus 6, by converting volts into microvolts, I have to write the same number 10 raised to 6, but instead of this minus, I have to write plus here. That's all. And then the further calculations are there that you can easily deal with. It's not a big deal. See, now here it was voltage, that is why we have written volts, not necessarily. Now say this is applicable for any unit. If it is current, it will be microamperes to amperes, amperes to microamperes, like this. If it is resistance, it will be micro ohms to ohms, and vice versa. So this multiplicative factors are applicable to any units. They're applicable to any units. Micro, milli, nano, these are simply multiplicative factors, whatever be the unit. That doesn't really matter.